All right, so this wants me to have a parallelogram here. If you just looked at 4 and you wonder why there was no video, I apparently am tired and I started doing the problem. Partway through, I realized that I had not talked yet. And I started talking, got done with the problem, and then realized I never actually recorded. So I'm not going to go back through and do a video for it. They all work the same. So here's a video for this. Draw an accurate diagram. 4, 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7. A, B, C, D. I have no idea why I've been graphing these. If you've noticed during this, I've been graphing them like point A, then point D, then point B. I've been graphing them all weird ways. It's fine as long as you remember that you have to make sure your graph is super accurate. So then there's BC, there's CD, there's AD. We'll zoom out. And there's AB. So I'm going to have a slope here. I have a distance. Okay, let's zoom back in and get our rises and runs drawn in here. So there's all my rises and runs. BC is down 1, right 5. CD is down 12, left 3. AD is up 1, left 5. And then we're up 12, right 3. So if I look at these right here before I go on and do anything else, 2 negatives makes a positive. And I can see right here that I've got parallel, and I can also see right here that I've got parallel. So I got 2 pairs of parallel sides. Okay, then I come over here, -1 squared plus 5 squared. So that's 36. So 144, 9, 153. And then 1 squared, -5 squared. So that's 36. And then 12 squared, 3 squared, z squared. That's 153. Okay, I got some congruent sides. All right, you can see there's some equal sides there. If I go over and look at what it says parallelogram. That's 2 pair of parallel sides. Okay, so 2 pair of parallel sides. I had that before I got the distances, and this is where if you're getting a little better at this, you might say, well, I don't need the distances then. You don't, okay? But if you want to be safe and do a little less thinking, just put them there, all right? But again, less work involves more thinking, all right? And that's the trade-off. So based on my calculations, BCD is a parallelogram because it has 2 pair of parallel sides with equal slopes. All right, so there's another one done. Got a couple more to do. But basically, once you see the process in these and you're sure, really the more important thing is to know how to prove things are a specific shape. And then once you know what those choices are that you have to make, these are pretty easy to deal with.